the concepts of sets. Last period we have discussed definition of sets, then how to express sets, then finite, infinite sets, empty sets, the other names of empty sets, void set, null set, the set containing no element, the set containing no element, that is your empty set or void set, then infinite set and finite set. The set containing finite number of elements is finite set. The set of infinite elements is infinite set. A set is said to be finite if it contains finite number of elements. A set is said to be infinite if it contains infinite numbers of elements. It depends upon number of elements. Already discussed. Now I will proceed to the last one, equal set and equivalent sets. Equivalent sets are not in your NCERT book, but I will discuss equivalent sets. Equal sets and equivalent sets. What is the basic difference between equal sets and equivalent sets? First we see equal sets. Two sets are said to be equal if they are equal. You can say easily, literally you can say, but the fact is that if we are considering two sets A and B, elements of A are present in B and all the elements of B are present in A. Again I'm telling, all the elements of A are present in set B and all elements of B are present in set A, then they are equal sets. Then equivalent sets, two sets are said to be equivalent sets if they have equal number of elements. Equal number of elements. Suppose A is a set, it has three elements. B is a set, it has also three elements. Then they are equivalent sets. But in equal sets, elements must be same, not the number. Whatever elements are present in A, all the elements of A are in B, and the elements of B are in A. They may be in different order, in different form. Suppose one set is written in set builder form, another is written in roster form, or elements are written in different orders. Inside the set, when we are writing in roster form, we will not consider the order. A set can be written in any order. Now, I will change the position of the laptop. I will focus to the board and I will discuss. I will write again all the concepts. Again, I will repeat with examples. Now, we are proceeding very slowly so that each and everyone will follow the concept, the basic concept. Give emphasis to understand the concepts. Once you understand the concepts, you can solve thousands of problems. You will not face any problem to solve the mathematical problems. Now I am focusing to the board, then I will discuss your problems. Now I will start with the board. So far as equal sets, see now, suppose a set is written A. The elements are written 1, 2, 3, 1. Another set you see B. It is written 2, 3, 1. Now you observe. Actually, the three elements are present in A. In A, in set A, exactly three elements, but it is written twice. One is written twice. If that element A, 1, is written many times, suppose it is written like this, but we will consider the set A has only three elements. Repetition of the elements will be not considered as more number of elements. Here element 1 belongs to A, 1 also belongs to B. Then 2 belongs to A, 2 belongs to B. Then 3 belongs to A, 3 also belongs to B. You check this. Is it? I mean, elements of set A are in B. All the elements of A, B are in A. So in this case, these two sets, set A equal to set B. These two sets are equal. Same elements may be written in different order, in different way. Suppose I will change it. Set here 2, here again 3, here 1, here 3, like this. What are the elements? Same 1, 2, 3. Here also 1, 2, 3. These are two equal sets. Suppose I am writing C, another set C. X such that X belongs to N and X is less than equal to 3. It is also same set. X such that X belongs to N and X is less than equal to 3. If we write this set in roster form, then our answer is 1, 2, 3. All are equal sets. These three are equal sets. Now we'll proceed to write what is the meaning of equivalent sets. Equivalent sets are not in your ancient book. Till then you see what is the meaning of that equivalent sets. Two sets are said to be equivalent if they have equal number of elements. Suppose X is a set. This set contains the element 1, 2. B is another set. It contains the element X and Y. Now, these two sets are two equivalent sets. X and B are two equivalent sets. X contain element 1 and 2. Y contain element, sorry, B contain element X and Y. I mean, X has two elements, B has two elements. So these two are equivalent sets. But X is not equal to B. They are not equal sets. X is not equal to B, but they are equivalent sets as they have equal number of elements. Again, I'm telling about that empty set. This is a finite set. This is also a finite set. Now, I'll write hi. Hi is a set. The number of element is 0 here. Another form of writing empty set. This is the curly bracket with no element. Curly bracket with no element. This is empty set. This is also empty set. But this one, phi inside the bracket, it is not an empty set. It is not an empty set. Why? It is a set with one element. With one element. This element is 5. So it is not an empty set. Such a set is called a singleton set. Singleton set means the set containing exactly one element. The set containing exactly one element is called singleton set. Singleton set, one element sets. Suppose one set is written here, set containing 0, the set containing x, now set containing 2, like this. Suppose we are writing x, y, z, it is a singleton set. The term is x, y, z. But when we are writing x, comma y, comma z, it is not a singleton set. It has three elements. X is an element, y is an element, z is an element. This set. But in this set, x, y, z, this total is an element. Here x is not an element. In this set, x is not an element, y is not an element. XYZ, XYZ is an element. But here X is an element, Y is an element, Z is an element. This is the difference. This is singleton set, but this is not the singleton set. It has three elements. Now we'll proceed to exercise 1.2. Exercise 1.2. Now you open the book. We'll discuss one by one problem. First I'll discuss 1-2 problem. Then you will do the remaining. First, which of the following are examples of the null set? Which of the following are examples of the null set? Null set is same as empty set. Set of all natural numbers divisible by 2. Is there any natural number present which is divisible by 2? No, there is no such natural number which is divisible by 2. Our set is given set of all natural numbers divisible by 2. There is no such natural number which is odd and divisible by 2. So this is an empty set or null set. Second one, question number 1, second bit, set of even prime numbers. Set of even prime numbers. If we consider set of even prime numbers, only prime number 2 is here. 2 is the prime number which is even. So it has only one element. All other even numbers are taken as composite numbers or even numbers, but not prime numbers. Only 2 is prime number. This is the only even number in the set of natural numbers which is a prime number. So 2 is even and prime also. If we consider all other even numbers, I mean 4, 6, 8 and so on up to infinite, these are even numbers but not prime numbers. All are composite numbers. They have more than two factors. More than two factors. So these are even numbers but not prime numbers. This is the set. So it is a finite set. It is a singleton set. It is not empty set. It is not empty set. So question number 1, second bit, set of even prime numbers. Set of even prime number is not an empty set, not a null set. Then proceed to question number 2. Question number 2. Do now question number 2. You did do the first two bits. Now immediately I will explain the concept. Question number 2. Our first bit is the set of months of a year. Our instruction is which of the following sets are finite or infinite? It's clear. It is a finite set. As we know, there are 12 months in a year. 12 months in a year. It is a finite set. Question number 2, second bit. Question number 2, second bit. 2, second bit. The set is written 1, 2, 3, and so on. When and so on written means it is proceeding up to infinite. All natural numbers. There are uncountable number of counting numbers. Natural numbers. So it is an infinite set. Question number 2, second bit. It is an infinite set. Number of element is infinite, hence it is an infinite set. Then proceed to question number 3. First bit. State whether each of the following set is finite or infinite. These are from real life situations or from mathematical situations. First bit. The set of lines which are parallel to the x-axis. Question number 3, first bit. Suppose this is your coordinate system. How many lines you can draw? Those are parallel to x-axis. Suppose this is your x-axis. This is your x-axis. This is your y-axis. How many? How many lines you can draw? Those are parallel to x-axis. Infinite. You can draw infinite numbers of lines. Those are parallel to x-axis. All lines are parallel to x-axis. So in this case, you can draw infinite numbers of lines. Hence, it is an infinite set. Then proceed to question number 3, second bit. Question number 3, second bit. The set of letters in the English alphabet. The set of letters in the English alphabet, it is very much clear to you all. There are 26 alphabets in English. So it is a finite set. A, B, C, D, and so on. If you write the second bit in roster form, our set is coming like this: A, B, C, and so on up to Z. As its last number is known to us, we can write first 3 and the last. When the number of element is written in sequential form, then we can write first 3, then the last. In this way, you can write all the elements of English alphabet in set notation. A, B, C, and so on up to Z. Up to Z means it is finite. There are 26 alphabets. Now you do question number 1, 2, 3. The remaining bits, write only answer. After writing only answer, you check your answer whether you have written it correctly or you have not written correctly. Just you write only answer, whether finite or infinite or empty. Write only answer and check your solution with the solution set given in the back side of the book. Exercise 1.2, question number 1, question number 2, question number 3. The remaining bits, write only answer quickly. So that I will proceed. Be quick. Proceed quickly. One musical sound is coming from our background. I think you all are hearing the sound. Rhythmically, the sound is coming. Cuckoo sound. Every day morning, we are enjoying here cuckoo sound. That is a natural sound in our environment. Work out quickly. Now let us see how many are present. Shubhasri Ratha, Ambikeya, Mahapatra, Sloko, then Jigyansa. Name is here Thiman, so I know him. Jigyansa, okay. Subhasri, Prachi, S. Subhasri is writing all the answers. Ayush Nayak, then Supriya Patra. Yes, question number 3, fourth bit and fifth bit. I will discuss now your doubts. Question number 3, fourth bit and fourth bit and fifth bit. Okay. Sloko, someone is shouting. Not someone, it's cuckoo sound. You know, it is a natural sound. Cuckoo sound is coming from our surrounding. Yes, ether jump. Very good. You have done. Arpita also present. Work out the problems, Arpita. You do the problems. Kosik. Yes, good morning. Jigyansa completed. Very good. Ayush also completed. Now, yes, Subhankari, Giri. Very good. You have also completed. Now, I will proceed to that question number 3, fourth bit and fifth bit. Our instruction is state whether each of the following set is finite or infinite. We have to check whether the sets are finite sets or infinite. We will apply our common sense, our day-to-day life counting, whether it is countable or not, whether we are able to count or not. We will ask the question to us whether we can calculate or not. When we are looking to the sky, how many stars are there in the sky? There are infinite. So that is an infinite set. Here in fourth bit it is written the set of animals living on the earth. Earth is such a place, it is still not known to all. Earth is such a place. Some places till today are not yet discovered properly. That is a big question. That is a controversial question. Here it is written on Earth the number of living one. So not possible to count. So it is treated as infinite set. The set of animals living on the earth, it is infinite. Living being means it may be inside the water. Living being, living animals, it is in jungle. Some places are not discovered yet. Still, how can you calculate the number of animals? So this question number 3, fourth bit is treated as an infinite set. Okay. Question number 3, fifth bit, the set of circles passing through the origin. Through origin, you can draw infinite numbers of sets. Through the set, through the origin, you can draw infinite number of circles. So both the cases you can write infinite. Okay, but in a book, the second bit is given finite. I think it is written finite. The set of circles passing through the origin is written finite. You write it as infinite. Number of circle, you can't count how many circles can be drawn. Infinite numbers of circles can be drawn, so it is infinite set. Okay, it is written in book, I think finite. No, it is infinite. Okay, both the answers you write infinite. Next, I'll discuss now question number 4. In the following set, in the following states, whether a equal to b or a is not equal to b. See question number 4, first bit. A, B, C, D. Question number B, sorry, set B, D, C, B, A. I have already told you all, there is no ordering inside the set. You can write in any order, irrespective of order. If elements remain same, those elements are in A. If they are in B and elements of B are in A, then they are equal sets. So first bit, they are equal sets. In second bit, you see 4, 8, 12, 16, 4, 8, 16, 18. The elements are different. Question number 4, second bit. these two are not equal sets. Your reason is that 12 is in first set, but it is not in second set, and 18 is in second set B, it is not in first set. So question number 4 second bit, it is not equal. I mean A is not equal to B. A is not equal to B. Next is question number 5. In question number 5, we'll say, are the following pair of sets equal? Give reason. One of the set is written in roster form, another written in set builder form. The sets written in set builder form, you convert to roster form. After listing the elements, then easy to compare. If a set is written in set builder form, write in roster form, then compare. Now I'm discussing on the board question number 5 and question number 6. Wait, just I'm focusing the board to the board. I'm focusing the laptop to the board. See now. I'll discuss now 5 and 6. Question number 5 and question number 6. Question number 5, A is written as 2, 3. Question number 5, set A, it is written as 2, 3. 2, 3. It is 2, 3. Two elements. Set B is written in roster form, in set builder form, X such that X is positive even integer. X is positive even integer and sorry, I have written the part from 4. X is solution of that equation. Sorry, I have written the wrong question. Question 5 second bit. X is here. X is solution of the equation x square plus 5x plus 6 equal to 0. Check now. X square plus 5x plus 6 equal to 0. If we solve this equation, it is x square plus 3x plus 2x plus 6 equal to 0. Then factorize, splitting the middle term, taking x common here, x plus 3, taking 2 common plus 2 common, remaining is x plus 3. Now taking x plus 3 common, we'll get x plus 2. Now equating each term to 0, x equal to minus 3 or minus 2. Equating this to 0, you'll get x equal minus 3. Equating this term to 0, you'll get x equal to minus 2. Now we are getting minus 3 and minus 2. But in A, the elements are 18, 2, 3. Our answer is coming minus 2, minus 3. So these two sets are not equal. What is your conclusion? The conclusion is that A is 2, 3. Set B is minus 2, minus 3. Hence, A is not equal to B. The two sets are not equal. Question number 5, first bit. You have to do the second bit. Both the sets are written in set builder form. We have to write in terms of roster form. We have to list the elements. Then we'll compare. Question number 5, second bit. You do first, then I'll discuss here. Whenever I'm telling the question, immediately you start to solve. When you will proceed to solve, some practical problem may arise. Question number 5, second bit. The sets are given. First one, set A. Question number 5, second bit. You all read yourself. Set A. I am writing that answer in the roster form. Here the word is given follow. For first, it is written FOLLOW. This is the word given. X such that X is a letter in the word follow. If we write the letters in set notation, our answer is F, then O, then L. Don't write L again and again. Then O, not required, write W. Okay? FOLW. When we are writing the letters in set notation, not required to write L twice, O twice. We'll consider once. If write set B, for set B, WOLF. This word is given. For first, from follow, we are collecting the letters. F written, then O written, L written. Don't write it twice. O is repeated, not required to write, already O written here. Then W. From this word, WOLF, if we write, we can write W, then O, then L, then F. Now check. All the letters of A are in B or not. All the letters of B are in A or not. F present here, O here, L here, W here. W, if you check in the reverse way, W here, O here, L here, F here. I mean all the elements of A are present in B. Elements of B present in A. It may be in any order. Irrespective of the order, the letters remain same. I mean elements of A are same as elements of B. Hence our conclusion is A equal to B. These two sets are equal. So it is easy to compare when the set is written in roster form, when we are listing the elements. Now proceed to question number 6. From the sets given below, select equal sets. It is a question you have to search. Compare each and every element. First you take A, compare A with B, C, D, E, F, G, H. That way. A has elements 2, 4, 8, 12. 2, 4, 8, 12. You see, is it present in other sets? Not in B. 2, 4, 8. 2, 4, 8, 12 is present in set C, but 2 is not there. Element 14 of a C is not in set A. A is also not equal to C. If you observe by the method of inspection, by the method of observation, you can say there is no equal set to A. Then proceed to B. Set B and set D. You can check 1, 2, 3, 4. 1, 2, 3, 4. Set B and set D, they are equal sets. When you are checking, select a set, compare that set with all other sets. Here, set A 6. Set A, it is written as 2, 4, 2, 4, 8, 12. 2, 4, 8, 12. Then set B. This set is 1, 2, 3, 4. 1, 2, 3, 4. Then set C. Here it is 4, 8, 4, 8, 12, 14. Then set D. In set D, 3142. 3142. And set E, the elements are -1 and 1. -1 and 1. Then set F. Set F, it has also two elements, that is 0A. 0A. F. Then G. G contain 1 minus 1. 1 minus 1. Then H. Last set is H. H is 0, 1. Now we'll compare 0, 1. If we compare, first we take A, check A with B, A with C, A with D, A with E, A with G. By observation, A with F and also H. With each and every set, if you compare with A is not equal to any set. Now leave A. Then B. Set B is same as set D. Check now. 1, 2, 3, 4. 1, here 2, here 3, here 4. So B and D are equal sets. B and D are equal sets. B equal to D. When you check B, don't go back. Already A is checked with B. B, C, they are not equal. B, D, they are equal. B, E, G, F, H. B is not equal to any other. Then come to C. C is also not equal. Why? Here 4 elements. Here different. Then D, already checked. Here they are not equal to E, F, G, H. Then E. E and G. E and G are equal. E equal to G. E is equal to G. Why? E contain -1, 1. G also contain -1 and 1. So E and G are equal sets. Then F 0A, nowhere 0A. Then H 0, 1, nowhere 0, 1. So only two pair occurring, B equal to D and E equal to G. These two are the B and D are equal sets. E and G are equal sets. You can write clearly B and D are equal sets and E and G are equal sets. In this way, you will write your answer. If you'll ask, your problem is over here. If you say equivalent sets, here you see A, B, C, D. These four are equivalent sets. They are not equal sets. Why? Each contain four elements, four distinct elements. E, F, G, H. These four elements, actually, these four sets are also equivalent sets. Why? Because they have two elements each. Two elements each. Here, two elements. They are equivalent sets A, B, C, D and E, F, G, H. These four are equivalent sets and these four are also equivalent sets among each other. Here. But they are not equal sets. Only equal sets are occurring B and G, E and G. B and D are equal sets. E and G are equal sets. This is our answer. Now, exercise completed. 1.2 completed. We'll proceed to the next concept. Before that concept, just to see, work out, set example 8. Only one example you do. Example 8, page number 8. Example 8, page number 8. Quick. Then I'll proceed. Now, the numbers is showing here 27. I will proceed another 10 minutes, not more than that. I will tell the basic concept of the next exercise. and few problems. Tomorrow I'll discuss the next exercise. Why I'm teaching in this way? I'm giving you scope to complete the exercise in advance so that you can tell me the doubts. Here you all have written Aman, Sunayana, Nivedita, Subhasri, Ayush, Smile, Jigyansa, Sloko, Tejas, then Subhra, Saloni, Pradipta, Sunayana, Swagatika, all have completed and your answers are also correct. As you have already written the answers are also correct. Okay. Tejas, when you are writing the sets, use your caps lock, capital letters. Name of a set is written by capital letters. Capital letters. Name of a set is taken in terms of capital letters. For elements, as per the given instruction, we'll use, otherwise we are using the small letters. For elements, it may be small, may be capital, no problem. But normally, for name of the set, don't use small letters, use capital letters. Okay. Now, thank you. You already responding me. Satyajit also completed. Very good. I expect your answer here. Now I'll proceed to the next. Next concept is subsets. Next concept is subsets, and in that subsets, I will discuss many things: power set and universal set, interval set. All these things are there. Today I will not tell all other things. Simply I will tell what is subset. Suppose A is a set, B is another set. If all the elements of A are present in set B, then A is called subset of B. Once again, I am repeating. If all the elements of set A are present in set B, then set A is a subset of B. We will not see about B, whether B contains some extra element or not required now. I will discuss later on. If this condition holds, all the elements of A are present in B, then A is a subset of B. Using this concept, all natural numbers are whole numbers. So, N is a subset of W. All whole numbers are integers. So, W is a subset of Z. We are taking Z as integers. Set integers is denoted by capital letter Z. In some books also, I is taken for integers. I is taken for integers. Next, all rational numbers are real numbers. So set of rational numbers is a subset of real numbers. Natural numbers, integers, whole numbers, rational numbers, and irrational numbers all are subsets of set of real numbers. Yes, just all natural numbers are whole numbers. Hence, the set of natural numbers is a subset of whole numbers. Look at the board. I'll discuss in the board. See now. I'll discuss 1.2 completed. I am proceeding to the basic concepts for exercise 1.3. Always I am giving more emphasis to basic concepts. If your fundamental is clear, you can solve all problems. Here, N, set of natural numbers. It is a subset of W. This symbol is called subset. This is the symbol for subset. And this symbol is proper subset. This one, in this case, may be equal. But in your book, We are using this for both the purposes, but we are using this is for subset and this is for proper subset. Proper subset and it is for subset. But now in your book, so far as the symbol is concerned, we are not using this one. We are confined to this only. So I'm not using this one. In the meaning, subset N is subset of W. W is subset of Z. W is subset of Z. One second. Happy birthday to you. Well, then set Z. Z means set of integers is subset of Q. Q written for set of rational numbers. Q is subset of set of real numbers R. Then Q dash. Q dash is for irrational numbers. Q for rationals, Q dash for irrationals. This is also subset of R. That N, W, Z, Q, Q dash. All are subsets of set of real numbers. That R sometimes we are writing R in this way. That R we are also writing in this way. These are called bold R. This is also for set of real numbers. Symbol used for set of real numbers. R. Again I am telling N set of natural numbers, W set of whole numbers, Z set of integers, Q set of rational numbers, Q dash for set of irrational numbers, and R set of real numbers. In one way, in one line also you can write by putting that symbol. They are subset of each other. Here A is a set. It is 1, 2. B is a set. 1, 2, 3, 4, like this. Now you observe element 1 present in B, element 2 present in B. I mean all the elements of A are present in B. Hence A is a subset of a B. Now tell me, is B a subset of A? Is B a subset of A? No. Why? 3 is not in A, 4 is not in A. Hence, B is not a subset of A. Here is B is not a subset of A, but A is a subset of B. Suppose I will write here A, B in this way. I want to change to new sets. Suppose here B is like this. 1, 3, 4 in set B. Now tell, is A subset of B? No. A is not a subset of a B. A is not a subset of B. What is the reason? 2 is not in set B. So in this case, A is not a subset of B. This is the symbol for not a subset. Just like belongs to, does not belong to. Similarly, subset does not subset. A is not a subset of a B. This is the concept required for the next subsets. Next period, I will discuss subsets, different intervals, then power set and universal set. All these things we'll discuss in the next period. Today, your homework is exercise 1.2. I think you have completed all the problems here. Still then, if any confusion, you can ask me in the beginning of the next period. Now, I want how many are present. The number is saying, so far as your number is concerned, it's 31 now. Number of live viewers is 31 here, showing so far as the registration is concerned. We have registered around 48 students. Out of 48 students, now 31 is present. Then I will tell after completion how many actually enjoying this period. Around 80 plus students are enjoying this period as I am keeping it in public mode. In this live, It is public to all. Those are subscribing the channel, they are able to see. Thank you. Now I'll conclude my class here. I am proceeding now very slowly. Have patience and remain present from the beginning to the end. When I am repeating the concept again and again, it is more beneficial for you, not required to read again and again. If you will sincere and putting full concentration in the class. Thank you all. Om Shubham. Then Shubhankari, Aditya, Sloko, Titli, Ayush, A. Sunana, Supriya, Pujarini, Aman, Datishreyas, Satyajit, okay, Om Shubham, yes, Subhasri. Thank you all. Now I am closing the class. I want your feedback whether this YouTube live is better for the subject or I will proceed to WhatsApp or Zoom or any other application. You suggest whether this YouTube live is better for our subject or not. I expect your feedback. After getting feedback, I'll try to improve my teaching. We are new in this trend. We are teaching for first time in this application. So I expect feedback from you all. Thank you all.